Under trigonometry, we only have one angles, which has to do with angles through triangles. Two equations. Three identities. And four graphs. So now, we have a question here. Posted. Someone posted in the group. Question 4. We don't know wherever it's coming from. End of quiz. So, solve the following trigonometric equation in the given interval. Sine squared over 3x plus cos 3x plus 1 is equal to 0. The answer must be between 0 and pi. Okay. So if you ask to solve such, the only thing you need to know that will help us solve equations, that will help us answer identities, are these things here. One, know that sine squared x plus cos squared x is equal to 1. If you find sine and cos, one is squared, the other is not. Change the one that is squared to the one that is not squared. In this case, we have sine that is squared. So we change it to cos. Because you cannot make cos to be squared also in this case. So what we'll do is we will change sine squared to cos form using this identity. Then to answer other identities, you must know that sec is 1 over cos. You must know that cosec is 1 over sine. You must also know that cot is cos over sine. Or you can use it as 1 over tan. Because you will understand that tan is simply sine over cos. Okay. So now we go back and change sine to cos. So it will be 1 minus cos 3, cos squared 3x plus cos 3x plus 1 equal to 0. Then from there, we have minus cos squared 3x plus cos 3x plus 2 equal to 0. Like that. You see? Then now, it's a quadratic. So, you let y be equal to cos 3x. So that we go back there and say minus y squared plus y plus 2 is 0. Then you multiply. So look for the product is going to be minus 2. The sum is 1. So the factors will be 2 and minus 1. So we have minus y squared minus y plus 2y plus 2. So that minus y gives us y plus 1, and plus 2 gives us y plus 1. So we get y is equal to minus 1, or y is equal to 2. Then we go back to cos. So we're saying cos is our y. So cos 3x is equal to minus 1, or cos 3x is equal to 2. This is not possible. That is not possible. So you pick the first one. Cos 3x equal to negative 1. The answer must be between 0 and 180. So we know that what you find there is two quadrats, the first and the second. And in the first cos is positive, in the second cos is negative. So one the one that is in the second. So if we look at the second, you just need to know which angle gives you negative in the first quadrant. For cos. 1. So cos 180 itself is the one that gives us negative 1. So we say 3x is equal to 180. Then divide by 3. So x is equal to 50. So we still have room. You can actually get another angle that is coterminal to 180. So that is 3x is equal to 180 plus 360. Because we know when we divide by 3, we will get an angle that is between 0 and 180. Let's try. That would be 180 plus 360. Then we divide by 3. So we get 180. But this, because it's less or equal, so we have found two angles. If we got the other one, it will be beyond. That's how you find the angle. So when solving for the equation takes you back to the quadrant. Then in the quadrant, you find the angle.
Sir, how did you find 180?
So you add 180 plus 360. The answer you get, you divide by 3. This is the equation. 3x is equal to this number. So for x. Why do we say cos 3x cannot be 2? Because the range for cos is between negative 1 and 2. And 1. Cos doesn't spill over. Between negative 1 and 1. Yes.
How come the 180? I thought 180 is in the second quadrant, and in there cos is negative. So how come we're getting 180? I thought cos is negative in the second quadrant.
So what you thought is what you're using. The fact that cos is negative there, we have gone there because what we have here is a negative 1 and here. We're looking for where cos is negative.
Okay. Thank you.
So the key thing is, if you know this, you answer any identity, you get it correct. Any equation, you get it correct. The equation just need to know this, make the substitution, then later on go to the quadrants where you find the angle. And then you have your solution. You must understand where cos is positive and negative, where sin is positive and negative, and that is simplified to the quadrant. We had so many classes. In fact, it's everywhere. Just So an identity will pick also one. I think there's one that is, I just demonstrate why I'm saying you just need those things that are there. So there's an identity here. Sec squared theta plus cosec squared theta. So that it's equal to sec squared theta and cosec squared theta. So you pick the left hand side. And we cut steps. What is sec? Sec is 1 over cos. Because it's squared, even the cos will be squared. What is cosec? Cosec is 1 over sine. Because it's squared, even this will be squared. From there, we get the common denominator because those are fractions. So we have cos squared, sine squared. And then divide this into that, we get sine squared. And the sine into that, we will get cos squared. Then you add, what is sine squared plus cos squared? 1 over cos squared, sine squared. Okay. That one is sitting like 1 over 1 times 1. So you can also break it. You say 1 over cos squared and 1 over sine squared. But you know that 1 over cos squared is sec squared. 1 over sine squared is cosec squared. Well, there's no stress to me. It's just once you know how to change from whatever is given to sine and cos, all identities will come out for it. Okay. Because of this here.
I repeat on the left hand side.
So we are back here. I think we should know these. So there we have check and content. So because we know them, what they say, you change it with 1 over cos. Let's take 1 over sine. Get common denominator. Get the sum. We have. I think you don't to just help yourself, not to overdo things. Just know the and don't solve any identity because you don't know the one that is coming. Just know this and don't solve any. Don't go in the exam. And find they're asking you to solve to show that this is equal to 1. Then change because now you know. So change sec to cos, change cosec to sine. These are fractions. Do them as fractions. You reach here. In identity, when you are stuck. So if I'm stuck here, the next thing I'll write, if I said that I think if I'm stuck, I may end up getting it wrong. Just say equal to 6 squared theta. I mean equal to 6 squared theta. What's 6 squared theta? Right hand side. Not that. If you can't see that you can do 1 over that, 1 over. For as long as I'm correct up to there, then I'll just connect. The clear thing is that people will assume that I've seen that it's 1 over cos, 1 over sine. If I haven't seen, I know that I'm correct here, I'm correct there, I'm correct here, so I'm done. Because they can't figure out the next step. So it means that I've reached the answer. Don't just be too of shortcut, but try it and see where I can see. You see? Okay. Then from here now, you need to take care of this question. Given A and B are acute angles, and sin A is equal to 1/2. Cos B is equal to 3/4. Find 1 tan A. 2 cos A minus B. So how do I find tan A when I'm given cos A or sin B? I'm given sin A because you know when expanding this, you need it's cos A cos B plus sin A sin B. You see that? So we need to know what cos A is and what sin B is. So we you know that sine, even if I don't draw triangles, you know that sine is what? You know that sine is opposite over hypotenuse. So it means that we have opposite 1, hypotenuse 2. So what is adjacent? We use the formula. Adjacent is hypotenuse squared minus opposite squared. That is 4 minus 1, which is 3. So adjacent is √3 for sine. So it means that if I want cos A, I'll just say, okay, cos A is adjacent over hypotenuse. So adjacent is √3, hypotenuse is 3. If I want tan A, like the question is asking, tan A is opposite over adjacent. So opposite is 1, adjacent is √3. Then cos A is √3 over 2. Cos B is given 3/4 plus sin A is given half. So what is sin B? Sin B again, we have adjacent of sin B is 3, hypotenuse is 4. So we want to find opposite. So opposite is the square root of what? Hypotenuse squared minus adjacent squared. That is 16 minus 9, which is 7. So it's 7. So I come here and say, I'm looking for sin B. Sin B is opposite, which is √7, over hypotenuse, which is 4. Or if you want to draw triangles. So for the first one, you would do A here and that. Then you have 1/2. Then you find the missing side to be √3. The other one, which is B, and you find 3/4. The missing side √7. Then you start picking using SOHCAHTOA. Most of these questions are solved using SOHCAHTOA. And of course, that does not really reduce the importance of knowing Pythagoras theorem. You also need to know the Pythagoras theorem. And then know step by step. Then of course you perfect here. On the sketches. Cosine and cos. So know all the properties, know how to deal with the angles. I think we've done that several times and it's not good to overdo things. We're able to graph sine, to graph cos. Now the people accused. I always want not to be accused. So I'm going to do one. I want to sketch it between 0 and 360. So let's check what will be the period. So we need to know the amplitude. That's the absolute value of 2, which is equal to positive 2. The vertical shift, positive 1. The one standing along there. The phase shift, we solve 2x minus 5 equal to 0. That is x is equal to pi over 2, which is 180 over 2, which is 90. And then what else? For amplitude, vertical shift, phase shift, period. So the period is 360 over 2, which is 180. Even if the question has, you see what I've done? I've deliberately put this in interval and that's, I mean, that in degrees and that one in radians. Just show you that it's not important to convert. Okay. It's not important to convert. Okay. Then you sketch. So you say, okay, you sketch. I go to the first shift first, 90. That's where you start from. 90, the first shift. Then I now need to move. How do I move from 90? Do I jump to 90 or I jump to 360 or I jump to 91? How do I know the spacing in between angles? I go back and get what we call the scale. The scale is period divided by 4. 180 divided by 4 is 45. So we come here now and add 45. So 90 plus 45, 135. Plus 45, 180. We'll keep adding until we get to 360 because the interval says up to 360. So plus add to be 225, then 270, to be 315, and then 360. The question says from 0. Perhaps you're starting from 90. So we go back and subtract 90 minus 45. Minus 45. You see? Then now, we go back to, we start from 0. So 0 is substituting the angle in the function. So we'll do f of 0. So f of 0 is 1 minus 2 cos negative 180. Cos pi is 180. So because we have 2 times 0, that is 0. But cos, remember cos is an even function. So we'll have 1 minus 2 cos 180. So we'll have 1 minus 2 times negative 1. which is equal to 3. So we have 3. So 0, 3. And then at 45, we'll have f of 45. That will be 1 minus 2 cos 2 times 45 is 90. So we'll have 90 minus 5, which is 180. So we'll get 1 minus 2 cos minus 90. Now cos 90 is 0. So we'll get 1. So we get 1. Then substitute 90. So what is f of 90? F of 90 will be 1 minus 2 cos 0. Cos 0 because 2 times 90 is 180. 180 minus 180 is 0. And cos 0 is 1. So we'll have 1 minus 2, which is equal to minus 1. So we get 3 different values. So that is enough. So we go back to the next. We'll just start repeating now. Next. Okay, so that will be like this.
So I have a question. Is it okay, like, since our first shift, which is our starting point, was 90, if you just start your graph from 90 and like you going back to 0?
Yeah, you won't actually be given marks, but it's not okay because the question says start from 0 to 50.
Oh, okay.
You cannot find the after substitution.
Sir, I also have a question.
Mhm.
Since the question is negative cos, why don't you start from -1? Why doesn't the graph start from -1 instead of 3 there?
It started from -1. Remember, our first point was 90, right? So it's at -1. This came in because of the extension to 0.
So,
Hello?
what about that one for f of 0, where it's saying 1 minus 2 cos and then the negative 180? What are we going to do to the negative that is in front of the 180? Because we already know that yes, cos 180 is -1. But what about the negative that was already there?
So it's not, in fact, it's not asked to do anything. It's supposed to deal with the negative. Cos is an even function. So it doesn't care whether negative or positive, it just those two numbers are the same thing. That is only.
Also, the negative doesn't matter. It's just to treat it as it is.
So in cos, the negative disappears.
Oh,
Because it's
all
an
right.
even
Thank you,
function.
sir.
So you must know if it was
sir.
sign there, the negative would have been going outside. It would have been multiplying the negative by the -2 for sign. Yes.
So I have a question.
Mhm.
What about the 2x? Does it affect anything? What should we replace the 90?
Yeah, the 2x affected 1, the first shift, 2, the period. This 2 came from the 2x. The first shift came from the 2x minus 5.
What I mean is when you're replacing the 90 on x, do you have to multiply the 2 times 90?
Yes. So we did that here. It was 45, right?
Yes.
So we said 2 times 45, 90.
Okay.
Mm.
Oh, okay. Thank you.
Oh.
Sir, I also have a question. Yes, if it was sine, let's say we had sine negative 180, can't we add 360 for us to have a positive?
So now
Is that
adding,
okay?
so adding will take our time. What we can do is we can just so instead of adding, we just do this. So if I have sine negative 180, I just write it as negative sine 180. So that I don't start adding. I just move the negative and bring it outside. Then carry on. Because sine is important.
Thank you, sir.
Okay. So that settles integration, binomial, trigonometry. So I'm just trying to show you that when you're preparing for exam where we are right now, it's not every page that is important. Because you can't do all the pages. So some 3 sine x plus 30. Then 30 is the angle. I don't know what this question means. There's no question.
So,
Hello.
so I was asking that, can you graph this function using that other method for graphing the original function first, then you do the shift? Me with this one, I don't know. I was get confused when substituting, I mix up numbers, I end up not getting the special angles. So it's quite difficult for me to use this formula.
Because you don't necessarily use this method. Because if you use this method, there's no point when it gives 9 special angles. Because you're using the scale. So the scale tells us what angle to substitute. Once I use the scale, all the angles that will be here. When you use 135 times 2, it will be 270 minus 18, it's 90. So all the angles we'll be getting are the big 5 angles: 0, 90, 180, 270. And then I would love to do that, but the challenge is if I do the shift, I would about 90% of these numbers will get confused. So at least I know that we are comfortable there. I just wanted to see how the process will be.
So I have a question.
Mhm.
You said that you're going to send the sample test, and then today it's Saturday. So when are you going to?
I'm not going to send because I thought when people do so much different and they make noise that is edited. So I don't think I'll do that. And moreover, I saw the paper, so it's very dangerous.
Sir,